yeah, when we get two polar curves involved, here's the process on this one. This is find the area inside one but outside the other. Okay, so that's one thing. Another thing we want to look at here. All right. Well, let's first of all just figure out what it is we're graphing or finding the area of. I've got these. I probably should draw them up here, but so first of all, yeah, r equals 3 sine theta is just it's just a circle. And then the 1 plus sine theta, it's a cardioid. Different color, but maybe you can see it. Different color. All right, so it's this. So I want inside the circle, but outside the cardioid. So the cardioid thing is the r equals 1 plus sine theta. Okay? Inside the circle, but outside. So hopefully you can visualize or see which part we're talking about. It's inside the circle, so it's got to be inside, but it's outside of the cardioid. And so what fits that those parameters is this right here, isn't it? This kind of a crescent moon shape. Well, on these, what this hinges on are these points. These intersection points, right? And how do I get the intersection points? I said the two things equal, right? 3 sine theta equals 1 plus sine theta. And they'll be pretty nice about these. So I mean, you can get some tough little equations, but pretty easily. But I think they're usually pretty nice about them. Let's see. If I subtract sine theta, I'll have 2 sine theta equals 1. So divide that by 2, we'll have sine of theta is a half. Well, sine of theta is a half. Theta, one angle would be, let's see, sine of 0, so it'd be pi over 6. Right? But you also have other quadrant angles where that's kind of the reference angle. Sine is also positive in quadrant 2, which that's the other one here. And so that would have a reference angle of pi over 6, which would mean that angle is 5 pi over 6. So it just depends on which quadrant you're in. This will give you, figure out that angle, and then the other one's that with that reference angle in the appropriate quadrant. Does everybody see how I got those? So, yeah, so it's pi over 6, and this one's 5 pi over 6, because it's quadrant 2. All right. Now, how do I get just this area, though? Well, here's basically what I'm going to do, is I'm going to take this area right here, which is the r equals 3 sine theta area, from theta equals pi over 6 to positive theta equals 5 pi over 6. I'm going to take that area, and that gives me too much area. So I'm going to take away, right? Subtract then the area of the cardioid. From theta equals pi over 6 to theta equals 5 pi over 6. Wouldn't that, so this area would give me all the way this area is the circular area except for these little pieces right in here. So I have to take away then the part that's in the cardioid. This blue, I didn't make it blue here, but this is the blue curve here for reference purposes. Maybe it'll help you there. Hopefully it shows up on the video. You see what I'm saying though? I subtract those two. So how do I get this area? Well, it's the area from pi over 6 to 5 pi over 6. 1/2, and then the r here is 3 sine theta, so it'll be 3 sine theta squared. And then minus the pi over 6, 5 pi over 6, 5 pi over 6, 1/2, and this is r equals 1 plus sine theta, so I do 1 plus sine theta squared. Yeah. And yeah, so that this is 1/2 9 sine squared theta d theta, and this is 1/2. You do have to square that out. So you have 1 plus 2 sine theta plus sine squared theta, theta. Well, all right. And these limits are the same. And so, if we do have the same here. If these limits aren't the same, which in the next one they won't be the same, so I mentioned that. But because these are the same, here I've got 9/2 sine squared, and here I'd have 1/2. Let's write it out. Just to make things a little easier on ourselves. Go ahead and distribute the 1/2 here. So what I'm saying is, yeah, since these limits are the same, I've got a 9/2 sine squared, and then this will be minus 1/2, minus sine, minus 1/2. So I've got a 9/2 minus a 1/2. That's 8/2 or 4. That'll make it a little easier on yourself, but I can only do that since these limits are the same. If they're not the same, I couldn't do that. So it turns into 4 sine squared theta minus 1/2 minus sine theta. I skipped a few steps there, but you see what I did? That's a minus 1/2, that's a minus sine, and that's a minus 1/2 sine squared, so I just combine that with that. It's a minus. So yeah, this, I'll let you finish this one out, but yeah, that you do the double angle, I erased it, but do the double angle identity there. And these two are just simple antiderivatives, but you should come out there with pi. Really? Pi. That's what I have. Of course. All else fails, just guess pi. Yeah, finish that up. You should get pi, because I wanted to get to this other one. Time frame here. So we've been through a couple. Same old there. Okay. So this other one, a little bit different. It is find the area inside both curves. Find the area that lies inside both curves. It's r equals 3 plus 2 sine theta, and r equals 2. Well, here's what this looks like. All right, so r equals 3 plus 2 sine theta looks like it's a cardioid. Okay, cardioid. R equals 2, that's easy. It's a circle. Radius 2, centered at the origin, the polar axis. So r equals 2 actually comes in kind of here, there, and then kind of goes out of this one. Yeah, it's not the best blue pin ever there. I don't think this one's any better, so anyway, all right. So r equals 2 is right there. Well, here's the deal. To get that, so it lies inside both. So if you look at piece by piece here, yeah, this little piece is inside both. This little piece is inside both. But then on these, I kind of have, if you look at it, you put these where the intersection points, if you look at it, I've got to do this piece, and then this piece, and then this piece. So there's actually two things going on. I've got from here to here swept out on the r equals 2. So r equals 2, the blue one. A little too big for my scale here. Not much better, but okay. So that's from here to here. I've swept out from here to here. The Pac-Man right there. But then I've got to get just the cardioid little piece. See what I'm saying? Just that little piece out of this whole big cardioid. It's not a subtraction, it's an addition. So if you're inside both, that's not a subtraction, that's an addition of two things. All right, now, I have to figure out, so these intersection points, well, set the 2 equal, so you got 3 plus 2 sine theta equals 2, just set the 2 r's equal. So you subtract 3, we'll have 2 sine theta equals -1, divide by 2, so we've got the sine of theta is -1/2. Well, for one thing, that's sine is negative in, like I said, quadrant 4 and quadrant 3. That's where sine, obviously, that's where we are. So one of this, it's -π/6, isn't that's one of the intersection points, -π/6. And so that means our reference angle is π/6, so we can get a lot of different angles. This would be a reference angle π/6 here would be pi plus π/6, so it'd be 7π/6 would be another one. And there's others. You just have to figure out which ones. Now, for this one, to go from this angle, sweep it all the way around to that angle, that is theta equals -π/6 to theta equals 7π/6, wouldn't it? That would sweep that out.
It's backwards for the other one.
Huh?
It'll be backwards for the other one.
Backwards for the other one?
would be at 7 pi over 6 to make.
Ah, well, all right, so on this one, I would actually need to start at 7 pi over 6, wouldn't I? And then go to this quadrant 4 angle, which is theta equals, the reference angle is pi over 6, but I want a positive. So that would be what?
9 pi over 6.
9 pi.
Or
Not 9 pi. If you go all the way around, it's 2 pi, right? And so I'm just going 2 pi minus the pi over 6, aren't I? Which is 11 pi over 6. Yeah, 11 pi over 6. So you just can't, it's just weird. You just have to figure out. So in this case, the two angles are different.
so you can't put them together like you did otherwise.
Well, yeah, you can't combine between the two integrals. This one actually is going to be fairly easy, so that's a good thing. What would be this integral here? From minus pi over 6 to 7 pi over 6. 1/2, so this is r equals 2, isn't it?
1/2 of 2, so 1.
So 1/2 times 2 squared, you got to square it. D theta. So yeah, that one's going to be easy. Plus the integral from 7 pi over 6 to 11 pi over 6. Is the cardioid, which is 3 plus 2 sine theta. So it'd be 1/2 the 3 plus 2 sine theta squared d theta. So not only do you have two separate ones, you're adding them, not subtracting them. And then the limits are different because you're sweeping out different areas. So, yeah, if we did from negative pi over 6 to 7 pi over 6 on this one, we'd be sweeping out that whole deal, which would give us way too much area. We only want this little piece right here. This one, we want that whole area. But on this one, we only want that. So, yeah, so this is a pretty easy integral here because it's just 2 d theta, so it's 2 theta, and just plug in those. So that one's fairly easy. This one, of course, you got to square that out, distribute the half, do the double angle because you'll have a sine squared. Altogether, if you do all that out, and I'm out of time here, I got final answer. I want to check 19 pi over 3 minus 11/2 square root of 3. As far as the exact value is concerned. Anyway, but it's really the same old there. So I'll let you finish that one off. See how that goes.